Today we are going to talk about systems of linear inequalities. A system of linear inequalities is a set of two or more inequalities that are related in some way. Today we're going to specifically focus on two sets of inequalities that are in a system. And to know if we have a solution to a system with linear inequalities, we will look for the shaded region that they share. So solutions of systems of inequalities lie in the overlapping region. First, we're going to focus on number one and how we graph and what that overlapping shaded region looks like. For number one, both of our inequalities are written in slope-intercept form. So what we're going to do is identify the slope, the y-intercept, and then the type of line and shaded region we're going to create for each line. For this first one, our y is a negative, or our slope is the slope-intercept of -1/1, and our y-intercept is b is -1. In addition, our inequality is going to give us a dotted line as well as a shaded region above that dotted line. Our second inequality has a slope of a +1/1, a y-intercept of -5, and then this inequality also gives us a dotted line, but this time it will be shading below. To graph the first one, our pink identified inequality, I'm going to start by going down to -1. Then I'm going to create a train of my slopes down 1/1 all the way through my graph. Then I'm going to connect these dots with a dashed line, making sure to have arrows at the end. When I go to shade, I want to make sure that I'm going above the line. So what I'm going to do is I'm going to put my pencil on the line and go directly up. This is going to help me see which side of that shade or of that dotted line I'm going to have to shade. Then I'm going to do the same exact thing with my other line, the blue one that we identified. The y-intercept is -5, but this time my slope is up 1/1, positive slope. I'm going to take the same approach and mark my line as clearly as I can, and then I'm going to create a dotted line connecting. This time my shaded region is below, so to help me see, I'm going to put my pencil on the line and go directly below. And in the process, I'm going to see a shaded region that's overlapping the pink and the blue occur. This is where our solutions lie. What we're going to do is we are going to identify one coordinate that satisfies this inequality system, and that is going to be something from that shaded overlap. So for example, 7, -2. Now, we also want to pay attention to the lines and see if we can pull a solution from the line. Anything that is a solution from the lines has to be touching or bordering this overlapping region. But what we have to be careful about is what kind of line that we are using. Here we have a dotted line. Here we also have a dotted line, which means we are not allowed to pull any solutions from this dotted line. Next, we're going to look at number 2. Again, we're going to start simple. We are going to pull from our first line with a slope of 1/3, a y-intercept of 7. Inequality tells me that I'm going to have a dotted line, and we are going to shade below. My second inequality, again, we are in slope-intercept form, so -1/1, y-intercept of 4, but this time we will be shading above the line with a solid line because of our equal to. Starting with our first inequality, our y-intercept of 7, we're going up 1/3. Now, we started to go off the graph, but we want to make sure we graph this point first before we start going in the other direction. Dotted line, arrows on the end. Here we are going to shade below. Now we are going to start our second line. We have a y-intercept of 4 and a negative slope. We're going to start off going down and to the right, and then continue our graph on the other side up and to the left. This time we are going to connect with a solid line because of our equal to component of our inequality. Shading, we're going to go above the line See an overlap occur with that purple region. Again, all of our solutions come from this shaded region, which means each person can pick a different coordinate that would satisfy. So for this example, I picked 5, 2. Now, when we're looking for a solution from the solid line, again, we can only pick something that is part of this overlapping region or bordering it. So the only solid line options available are starting here at the coordinate and going all the way through. I'm going to pick 0, 4. Now, one thing we have to be careful about is where these lines intersect. This is our intersection, and this is the only point on the solid line that's bordering that we cannot pick. The reason why is the location where it's intersecting with the dotted line is on the dotted line, which means we cannot use any of these points from that dotted region. The only ones we are allowed to use are ones on this solid line that are also part of the blue region down here. Once we hit the line up here that's dotted, that's no longer a solution. Looking at our next example, we can first start with the second system for ease that it's in slope-intercept form. Our slope is 2 over 1, our y-intercept 1, we have a solid line, and we're shading below. Now for our first inequality, we have some work to do to put this into slope-intercept form. So what I'm going to do is I'm going to copy the exact inequality down first and then begin solving for y. My first step is I'm going to subtract x from both sides, leaving me with negative 4y less than or equal to negative x plus 24. Then I'm going to divide by negative 4, and what I need to be careful about is when I divide by that negative, my sign will flip. Then every single number is being divided. So this negative 1 divided by negative 4 is positive 1/4 x. 24 divided by negative 4, negative 6. Slope is 1/4, y-intercept negative 6. We will have a solid line that we are shading above. Pink inequality, we are going to begin at y is 1, and we will rise to run 1. Then we will go down into the left, connecting with a solid line. Shading is going to be below, so again, we will put our pencil on the line and shade down. This is going to help us see which side of the graph we are shading. Sometimes it tends to look like there's a right and left region instead of up and down, so putting your pencil on the line and going that direction will help you see which side. Our second inequality, the blue one, we will start at our y-intercept of negative 6. 1, and we will run 4, and then we will go the opposite direction. The solid line, and again we will shade in the direction indicated, which this time is above. Pencil on the line, and when we move up, we see this shaded overlap occur in that purple region. Coordinate that lies in that shaded region is considered a solution. So for me, I will pick 3, 0. Now, for our line solutions, both lines are solid, which means you can pick any coordinate from the blue as long as it's touching that purple, or any coordinate from the pink as long as it's touching the purple. The only areas we can't use are anything past the overlap. In this situation, because both lines are solid, the location that they intersect is also a usable point since both are using that coordinate. I'm going to pick an easy point to read, so I'm going to pick 0, 1. This example, we're going to look at a unique feature, and that is when we are missing a variable in one of our inequalities. Before I address that, we're going to start with our second inequality and rewrite it below. The first thing I'm going to do is move my x using opposite operations. So I'm left with 2y less than or equal to negative 3x minus 2. Next, I'm going to divide by 2. This time, I do not have to flip my sign because I'm dividing by a positive value, so our signs don't change. Remember, every single number is being divided, so my slope turns out to be a -3/2. My y-intercept is -2. We will have a solid line, and we will be shading below. Now, for our unique situation. In our first inequality, we don't have a y variable, which means we will actually only be graphing in regards to the x-axis since we're talking about the x variable. Here they're telling us x is at -4, so on our graph, we are going to go specifically to where the x-axis is -4, and we are going to make a coordinate. The type of line that we are going to use is a dotted, and we are going to be shading below. When I am drawing this line, I'm going to create a vertical line. So this is allowing me to see that no matter what y value, whether we go up or down, your x is always going left -4 to this line. Now, where this can be tricky is when we're reading our expression. Technically, our symbol says to shade below, but if we look on our graph, there is no up or down, there is only left or right. So we have to think about what it means for x to be less than -4. If we remember, our axes are just number lines. So this is +1, 2, 3, 4. This is -1, -2, -3, -4. If I want the x values that are less than -4, that means I'm going to shade the region with the lesser values, which means to the left of the line that I just drew. This is where all my x's are smaller or below -4. For our other line, everything will remain the same. We're going to start off with our y-intercept of -2. And a rise, this time it's going to go down, of -3 over 2. Continue the first way, and then we'll go the opposite direction, up 3, left 2. This one we will connect with a solid line, and we will be shading below. Again, for these ones, we put our pencil on the line and shade in the direction. So below kind of looks like to the left in this problem. Again, when we're looking for solutions, we're looking in the overlap region. So for the shaded region, I'm going to pull -5, 1, which is this dot right here. For the line, again, we can only access the solid line, remembering that since that blue line is dotted, we can't use their intersection. So for my line, the easiest coordinate to read is going to be -6, 7. Try 5 and 6 on your own. The key will be posted online.